What we'll be looking at in this video is writing an inequality from a number line. Well, in the previous video, we actually represented an equality on a number line. So we want to do the reverse of that. And so we can actually read a number line with an inequality being represented on the number line. And we could actually rewrite it or do the reverse and to write from this number line what we call in the inequality form. So let us label our number line. Four, five, six, 7, 8, 10, 9. We have -1, -2, -3, -4, -5, -6. So my number line is not perfect, but I hope you will get the understanding. So let's start anywhere on this number line to see how it actually works. So this is a very simple one. So let's say I am at 2 and I actually have an open here and I'm heading in that direction. Now we can actually use x as the variable. So what is this saying to us? Well, one of the things that we must take into consideration or try to identify as we try to write from the number line into the inequality form is to look at where is the location of this inequality. Where is the location? It is actually at 2, but the question is, it is at 2, but is it closed or open at 2? And that's one of the biggest questions that you ask yourself. Now let us go back to understanding the signs of the symbols of the inequality. So when we have this symbol or this one, it doesn't matter which one, this simply means it is either greater than or equal, it's either greater than or less than. And so if we had these, which are somewhat different, these are saying it is equal to or greater than, it is greater than or equal to. Or you could say it is less than or equal to. So these two would actually satisfy, well, it can satisfy any condition at the time, depending on what the solution might be, and depending on what specific solution you're going to use to evaluate this inequality. And so we should actually look at these to say, okay, is it closed? So these signs are actually open signs. And these are the ones that are closed. And so we can actually know which one of these inequalities to write down as we continue reading and trying to put everything together. So let's go. So when we look at this as an open, therefore it is going to be one of these signs. But how do we know which one? Well, the direction of the arrow tells us. So the arrow is telling us it is greater. We're seeing that it is not close that 2. That simply means it's the value. Well, 2 is not a solution. It's not a solution. But greater than 2 is a solution. So any number greater than 2 is a solution. And so then we'll actually represent this as saying x is what? Greater than 2. And that's it. Then you should choose any random number that is greater than, not 2, -2, sorry. If you should actually choose any number that is greater than -2, this will satisfy the statement of being true. Even if you want to pick a negative number, a decimal number, if you want to say -1.5, that will be true, -1.5. Negative 1.5 is greater than -2. And so that is what we actually do when we are trying to identify or to write from the number line into the form of the inequality. So the first thing that we do, we look at where the location is. Is it closed? It is open. It, and where is it going? Is it going left or is it going right? Which indicates greater or less than. Let's look at another one. So say we have a close here. This is closed. And this is heading in this direction. Now how would we actually represent this? So the first thing we ask for ourselves, where is it? Where is the starting point? Where on this location it is indicating? It is indicating at 2. Is it closed at 2 or is it open at 2? It is closed at 2. Therefore, we are going to have one of these. One of those. And so, but how do we actually find the solutions of x? Then we will actually look at the arrow. The arrow is pointing below negative 2. And therefore, x would be below negative 2. Which is the same thing as x is or either equal to negative 2 or less than negative 2. So if we should choose negative 2, this will say negative 2 is equal to negative 2. If we were to choose negative 3, we could say negative 3 is less than negative 2. And so that would satisfy the statement to be true. Let's look at another one. Now, how would we actually write this inequality? Well, this doesn't look like the regular inequality. This looks like what we call a compound inequality, where you have more than one inequality coming together to form two inequalities as a boundary. So it is actually the solution of x will be confined to a lower end and an upper end. And so this is what we call a compound inequality. And so you're going to see what a compound, we would have seen it in previous videos that we looked at. So let's look at this. How do we read this? Well, this is saying it is at 2. Is it close at 2? Yes, it is close at 2. Therefore, we're going to have one of these signs. Now, we could actually write this part first. We could actually solve that part first. So, we'll actually, so this say it is close at 2, and it is heading great. It is heading in this direction. That simply means it is close at 2, or it is greater than 2. Therefore, we must write x is, negative 2. X is greater or equal to negative 2. And so if we should actually look at the other side of this side. Now it is at 4, it is not close at 4. Therefore, and if we actually, it is heading in that direction, so it is going less than 4. So it must be, x must be less than 4. And so this will be the compound inequality that shows the boundary of the solutions. So the solutions are from negative 2 go up to 3.99999999999999999. And so we actually can see the clear picture of representing from this inequality. Let's look at another one. Representing from this number line. Let's look at another one. So what if we had let's say we had trying to make it close right here. Right. So how would you actually read this? Well, it doesn't matter which end you want to start from. You can start from this side if you want to. We want to start at this side. It doesn't matter. Well, we love to explore different directions. So let us start somewhere that we have never started before. So let's start at this one. What this is saying? This is saying it is at 7. It is closed at 7. Therefore, we must have a sign that has an equal in it. And so what this is saying? This is saying that since it is going in this direction, that simply means it is going less than 7. And so x must be less or equal to 7. And so when we go here, we do the same reasoning and reading. So it is at 2, it is close at 2, and it is actually going greater than 2. Therefore, x must be greater or equal to -2. And there you go. Oh, where I got 2x from? There you go. So there you go. X is greater or equal to -2, and it's a compound inequality, and less than or equal to 7. So if you should choose any solution, so the solution of x that actually would satisfy this inequality, or to make the statement true, we must find a solution between these two boundaries, the -2 and the 7 exactly. Either it is -2 or it is greater than -2. Either it is 7 or it is less than -7. So those solutions would actually make the inequality true. Let's look at another one. Say we have enough of that too. How would we write this one? Now we will do the same approach. We look at where at what number it is actually indicating. So if we look at this one, it is actually at 0. Is it closed or is it open? It is open, therefore we're not going to use this one, but we're going to use this one. And so we know what we're actually doing. So we could actually write it. We could say, and it is actually going, it is indicating greater than 0. Because if you should start at 0, and if you should walk on the line, you're actually going up. So you're actually greater than 0. Your steps are increasing, so you're greater than 0. So then we have x is what? Greater than 0. So that's just the first part. And let us join the other part of it, because it is a compound inequality. And so it is at 2, but it is not close at 2. And it is heading down from 2. So it is actually x is less than 2. So we read x is greater than 0 and less than 2. So if you should choose any one of these solutions between 2 and 0, it will make the inequality true. And so there you go. Writing inequalities from a number line. So let us recap. The first thing that we do, we indicate where the locations are. Is it closed? Is it open? And then we'll choose the inequality symbols based on the condition. And then we look at the direction in which the lines or the arrows are pointing. If it is pointing up, it is greater than. If it is pointing down, it is less than. And we always read from the x. We always read from the x because the x is the subject of this inequality. And so we will actually treat x as the preference in this situation. I hope this video will actually help you a lot, and it will clarify all the misconceptions, and you'll actually learn new things from this video. Remember, if you like this video, please share, subscribe. like, leave a comment, and I will see you next time.